day, grade 11s. Okay, so today we are looking at analytical geometry, question 3, 2019, November 2019 paper. Okay, now let's go through the question. It's saying in the diagram, A, negative 0, 2, negative 2, 2, B is written there, for negative 4, negative 6, C, as we can see on the diagram. These are the vertices, so A, B, C, E are the vertices of quadrilateral having AE parallel to BC. Okay, D lies on BC, D lies on BC such that AD is perpendicular to BC. Okay, AC is drawn. Now we've got AC is drawn, and MX2 is a point on EC. Okay, so now given the information that we have here, you can deduce something here. We know that A is given AE parallel to BC. What does it tell us? It tells us that gradient of AE is equals to gradient of BC. Then another thing is what? We are told that AD is perpendicular to BC. What does it mean? AD perpendicular to BC. We can now know that gradient of AD times gradient of BC must give us -1. So already you've got this thing, what you call this information. You must write this information, please. What you call aside. It will actually assist you because you're going to use it. They can't just give you just to read. No. Now, let's go from the question. First question: calculate the gradient of BC. Gradient. We know that gradient is change in y. M is equals to y2 minus y1 over x2 minus x1. So here you can just make your y2 n of them. We want to find MBC, okay, BC. So we can take any, we can start with any, but once you start with one of these, let's say you start with a B, it means you're going to start with -4 and also with -6. So here, let's start with the -6 minus -2 over -4 minus 4. Then what do we get here? We get -6 plus 2, we get -4. Negative is going to give us -8. Okay, then we can get 1 over 2. Okay, so here also another thing to see there, if you find your gradient negative, you know that it's wrong because this is an uphill. Your gradient should be what you call positive always. Okay, let's check. Let's go to question 3.2. If M is a midpoint of EC, M is a midpoint of EC, determine the values of X and Y. This, you need to understand this very well. For us to calculate, to find the coordinate of the midpoint for X value, we say 6 plus 4 over 2 must give us X. That's what we know. So from there, 6 plus 4 is 2. So X, we can get it as 5. So we get X as 5 there. Then in terms of Y, we know that if we add these 2 again, we divide by 2, we get 2. So we're going to say Y plus minus 2 over 2 must give us 2. So here what we do is going to be Y minus 2. Let's shift to that side. It's going to be 4. 2 times 2 is going to give us 4. Then what else do we have here? We're going to take 4 that to that side. Y is going to be equals to 4 plus 2 is going to give us 6. So Y is going to give us 6. So that's your values of what X and Y. Now let's move on to question 3.3. Calculate the length of BC. Length of BC, we know length of BC is going to be equals to root of X B minus X C squared plus YB minus YC squared. Root of that. What do we get there? Let's see, it's going to be root of, for b, we're going to say it's going to be minus 4 squared plus, what do we have here? We have got negative 6 minus 2, minus going to give us plus, so it's going to be plus 2 squared. Then what do we have there? We have got the root of negative 4 is give us 8. 8 squared is 64, so it's going to 64 plus, then negative 4 plus negative 6 plus 2, we get negative 4. Negative 4 squared, we get 16. Then this is going to give us root 80. Okay, that's so when you punch root 80 in your calculator, root 80, you get 4 root 5. It's gonna be 4 root 5. That's your answer there. Then let's move on. 3.4 is saying 3.4. Okay, if it is given, it is further given that AE is root 80, to which group of special quadrilaterals does A, B, C, E belong? It belongs to what you call what is it? Parallelograms. Parallelogram. So this is actually a parallelogram because opposite sides, they are parallel and they are also equal. That's actually a property of what we call parallelogram. Now determine the equation of AD in the form of y is equals to mx plus c. Now here is a thing to understand here. Okay, so we are asked to find equation of AD. Now remember, to find the equation, we need to have one coordinate. For equation, you need to have one coordinate and gradient. That's only what you need to find that. So you use the equation y minus y1 is equals to mx minus x1. So your x1 and y1 being your coordinate, you choose any of these coordinates. Okay, so that's what you need to understand there. Now, what do we need to do here? We know that for AD, we have got A as our coordinate, but we don't have the gradient. But now, let's come back to what I've indicated earlier. What did I say here? We said MAD times MBC must give us -1. So we know that gradient of AD times half, which is a gradient of what is it? A BC, gradient of BC times half must give us -1. Therefore, MAD, we get it as -2 because we take the 2 that side, it's going to be -2. That's how you get your gradient here. Now, so what do? We come and substitute in our what call, we come and substitute A as our coordinate, as our x1 and y1. We say y minus 2 is equals to -2 x minus 2 is going to give us +2. That's why we're getting +2 there. So let me just put it in as it is so that you understand. Now here minus is going to give us y is going to be -2 is going to give us -2x plus, because this one is a plus inside there, so we're going to get -4. Then we take 2 that side, y is going to be equals to -2x minus 2. We take 2 that side, is going to be what is it, +2 minus 2. That's what we have. That's our equation there. So that's our answer, is our equation. So I think you understand there. Next time when you're given that lines are parallel, you know that you also have they are given the gradient there, or once you get a gradient of one of the lines. Now calculate the coordinates of D. Now we want to find D, but D is a point of intersection of D is a point of, this is 3.5. D is a point of intersection, of AD and BC. So what must we do? We must find equation of what is it? of, in this case, we have equation of AD, must find the equation of BC. So we're going to say, all right, equation of BC, we say equation BC, what do we do? We're going to say y minus y1. What do we have? We're going to use n of the coordinates. We can use c. C is 4 and -2. And we know that the gradient, we already find the gradient here. Gradient of BC, we have it as half. So m BC is equals to 1 over 2. Already we have that. So we're going to say y minus 2 is equals to half x minus 4. Then we take y plus 2. It's going to give us 1 half x minus 2. Then we take the 2 that side. It means that what? It means it's going to be negative. So it's going to be negative. So it's going to be y is going to be equals to half x minus 4. So now we equate the equation to find the coordinate of what? Of D. We equate the two equations. What do we have here? We're going to say, what is it? Negative 2x minus 2 must be equals to half x minus 4. Then what do we have? We have, what do we get there? We're going to get negative 2x. We bring it this side. It's going to be negative 3 over 2. Negative 5 over 2, negative 5 over 2x is going to give us negative, negative 2. We take the 2 that side. It's going to be x is going to be, let's divide by negative throughout. We get positive there. So x is going to be equal to 4 over 5. That's our x. Then we take x and substitute in one of the equation. Y is going to be equals to, let me check something here. Okay, so here we're going to get 4 over 5 times 1 over 2 minus 4. We cancel that. 2 over 5 minus 4. What do we get? 2 over 5. 2 over 5 minus 4. We get negative 18 over 5. We get negative 18 over 5. That's our what you call it, our x, what is it, our y value. So therefore your D is going to be equals to 4 over 5 negative 18 over 5. That's our D. Now let's move on to the last equation. Last equation is asking us to find determine the area of AEC. AEC, now when we have got AEC, we use the what called area of area, we use half base times height, perpendicular height. Now the perpendicular height in this case is your AD. So AD is H. So we don't have the length of AD. We need to find AD first. So to find the length of AD, we know that is going to be root of AD is going to be equals to root of 2 minus 2 minus, let's start with negative x, sorry, minus 4 over 5 squared, okay, squared plus, in terms of y, it's 2 minus, it's going to be minus plus 18 over 5. Remember, we're finding the equation, the what call the length of AD as our perpendicular height. Let's see what we get there. We get negative 2 4 over 5. We square that. We're going to add. We say 2 plus 18 over 5. What do we get there? We get error. Yeah, so we get 14 root 5 over 5. Now we know that our area is going to be half of what is our base. What is our base? We said our base is AD, half base AD. What is our not our base? Our base is AE times your AD as your height. This is gonna give us half of what is our AE? AE, we find it already as root 80 times 14 root 5 over 5. What do we get there? We get, let's punch the, okay, get 28 units squared, because it's an area, so we say units squared. Since there is nothing that is specified there, it's actually units what called squared. Okay, so we can send you also the paper, the what called the notes. You can request on WhatsApp, there's no problem. And also for extra classes, if you want what called some extra one-on-one classes, online classes, there's no problem, you can actually contact us. Okay, thank you so much.